Hello, my name is Daniel, and today we will be going through the AMC 12A from the year 2008. So let's get started. First problem: a bakery owner turns on his donut machine at 8:30 a.m. At 11:10 a.m., the machine has completed 1/3 of the day's job. At what time will the donut machine complete the job? Okay, so 1/3 of the job. So that took 2 hours and 40 minutes, right? So that took 2 hours and 40 minutes. And so multiply that by 3. This will give us the whole day's work. That's 6 hours and 120 minutes, which equals 8 hours, right? And so that's just 8:30 plus 8 hours. So 8:30 plus 8 hours is equal to 16:30, which is equal to 4:30 p.m., right? 4:30 p.m. That's our answer. Yeah, so it's D. Number 2, what is the reciprocal of 1/2 plus 2/3? So this is just equal to 3/6 plus 4/6. This equals 7/6, right? And so we want the reciprocal of that, which is 6/7. So this is the answer. It's A. Number 3, suppose that 2/3 of 10 bananas are worth as much as 8 oranges. How many oranges are worth as much as 1/2 of 5 bananas? Okay, so this much is 20/3 bananas. 20/3 bananas equals 8 oranges. And we want 5/2 bananas. 5/2 bananas. And so to get this, we have to multiply 3/8, right? And so we just multiply 3/8 to 8. So that becomes 3 oranges, right? And so the answer is 3 oranges. It's C. Number 4, which of the following is equal to the product of this? So we can just see that these two are just cancel out all the way up to 2004. This is 2008 over 4, which is 502. That's the answer. It's B. Number 5, suppose that this is an integer. Which of the following statements must be true about x? Okay, so this is x times, and then it's 2/3 minus 1/6. This is equal to x times 1/2. Since this has to be an integer, that means x is even, but there are no other restrictions, right? So it is even, but not necessarily a multiple of 3. That's B. Number 6, Heather compares the price of a new computer at 2 different stores. Store A offers 15% off the sticker price, followed by a $90 rebate, and Store B offers 25% off the same sticker price with no rebate. Heather saves $15 by buying the computer at Store A instead of Store B. Where's the sticker price of the computer in dollars? Okay, so if we say that the sticker price, this is equal to X, right? Then it's 15% off, so it's 0.85X, and then $90 rebate, right? So X and the minus 90, this equals 0.75X, right? Because that's 25% off, but then this was $15 cheaper, so this is also minus 15. Move that there and move this there. Yeah, then that will give us 0.1x. So 0.1x, this is equal to 75. So x is equal to 750. X is 750, that's the answer. It's A. Number 7, while Steve and Leroy are fishing 1 mile from shore, their boat springs a leak and water comes in at a constant rate of 10 gallons per minute. The boat will sink if it takes in more than 30 gallons of water. Steve starts rowing towards the shore at a constant rate of 4 miles per hour, while Leroy bails water out of the boat. What is the slowest rate in gallons per minute at which Leroy can bail if they are to reach the shore without sinking? Okay, so since Steve starts rowing at 4 miles per hour, but then they're fishing 1 mile from shore, this means that they need at least 1/4 hour. So they need 15 minutes, right? But then the boat will sink if it takes in more than 30 gallons of water, and water comes in at 10 gallons per minute, right? So the water incoming, that's 15 times 10, so that's 15, so that's 150 gallons. 150 gallons total, right? And then since the boat will sink if it takes more than 30 gallons, then at least 120 gallons have to be bailed. Right? And so we have to bail in 120 in 15 minutes. So it's 120 divided by 15, which is equal to 8 gallons per minute, right? So it's 8 gallons per minute. It's D. Number 8, what is the volume of a cube whose surface area is twice that of a cube with volume 1? Okay, so since the surface area is twice, that means the area ratio is 2 to 1, right? And that means the length ratio, this is, that's the square root, right? So that's root 2 to 1. And then we need the volume, right? So the volume ratio, that will be this cubed and this cubed, right? So that will just be 2 root 2 to 1, right? So this is the volume ratio. It's 2 root 2. It's C. Number 9, older TV screens have an aspect ratio of 4:3. That is the ratio of the width to the height is 4:3. Right, so this is 4 and this is 3, like that. The aspect ratio of many movies is not 4:3, so they are sometimes shown on a television screen by letterboxing, darkening strips of equal height at the top and bottom of the screen as shown, like here and here. Right? Suppose the movie has an aspect ratio of 2:1 and is shown on an older television screen with a 27-inch diagonal, whereas the height in inches of each darkened strip. Okay, so we see that from here all the way up to there, that's 27 inches, right? And then since this is 4:3, that means this length and that length, those lengths are vertical. Yeah, so the vertical length, this is 27 times 3/5, and the horizontal, that's 27 times 4/5, right? And since the movie has an aspect ratio of 2:1, that means since this is 27 times 4/5, then this is 27 times 2/5, right? This much is 27 times 2/5, and so the height of each darkened strip, that is vertical minus the actual movie, right? So that's vertical 27 times 3/5 minus the actual movie, which is 27 times 2/5 all over, and then this is 2 strips, so we have to divide it by 2. So this is equal to 27 times 1/10. This is 2.7, right? So this is 2.7, that's the answer, it's D. Number 10, Doug can paint a room in 5 hours. Dave can paint the same room in 7 hours. Doug and Dave paint the room together and take a 1-hour break for lunch. Let T be the total time in hours required for them to complete the job working together, including lunch. Which of the following equations is satisfied by T? Okay, so T, this is actual work hour plus the lunch hour, right? So that's just plus 1 hour, right? So that means working hours, this is T minus 1, right? When they work, Doug paints at 1/5 per hour, and Dave paints at 1/7 per hour, right? So that would be 1/5 plus 1/7. This much is the time they worked, so that's times T minus 1. This is equal to D, so the answer is D. Number 11, 3 cubes are each formed from the pattern shown. They are then stacked on a table, one on top of the other, so that the 13 visible numbers have the greatest possible sum. What is that sum? Okay, so we have a top cube from which 5 numbers will be shown, and we have 2 bottom cubes from which 4 numbers will be shown each, right? We just want the bottom unseen part to have the lowest value, so that will be this one. And so this sum would be 2 plus 4 plus 16 plus 8 plus 32. That's these 5 numbers, with this one being at the bottom, right? And so this is equal to 62, right? And then these ones, that will be choosing from these two, or these two, or these two, whichever their sum is smallest, right? And that's 4 and 8, right? So these will be the hidden parts, and then these will be the shown parts. So that's 1 plus 2 plus 32 plus 16, that is equal to 51, right? So since we have 2 of these, we need 51 times 2 plus, and then 1 of those, so plus 62. And this is going to be equal to 102 plus 62, which is 164, right? So this is 164, it's C. Number 12, a function f has domain 0, 2 and range 0, 1. And this is x is between a and b. What are the domain and range respectively of the function g defined by gx equals 1 minus f of x plus 1, right? Okay, so since this is x plus 1, that means x plus 1 has domain 0 and 2, 0 to 2, like that, right? And so that means that x is from -1 to 1, right? So those are these, and so these are all out, and we want the range, right? And the range is 0 to 1, but that's just for f, since f is between 0 and 1, right? And so negative f is going to be between -1 and 0. So 1 minus f is going to be between 0 and 1, right? And so we want the value of 0 and 1. So this is our y value, that's this one. So the answer is B. Number 13, points A and B lie on a circle centered at O, and AOB equals 60 degrees. A second circle is internally tangent to the first and tangent to both OA and OB. What is the ratio of the area of the smaller circle to that of the larger circle? Okay, so if we bring out that diagram, it's going to look something like this, right? And we're going to have this A and O and B, like that. And this is going to be 60 degrees, right? And so if you draw a line from O up to AB like that, right? Like that. And we draw more lines as the radius from here to there, like right there, that's the center. and from here to there also. We can say this length is r, right? So if that's r, then this much is r, right? And so since this is 30 degrees, and this is 90 degrees, that means this is 2r, right? So this is 2r. So the radius of the smaller circle, that's just r, right? And the radius of the larger circle, this is 3r, right? And so the length ratio, this is going to be 1 to 3, that's r to 3r, right? And so the area ratio, this is going to be equal to 1 to 9, right? Because that's this squared, that's that squared. And so it's going to be 1 to 9, so this is going to be 1 over 9. So this is the answer, it's B. Number 14, what is the area of the region defined by the inequality this? Okay, so this is 3 times x minus 6, no, sorry, 3 times the absolute value of x minus 6. And this is 2 times the absolute value of y plus 7 over 2, right? So this means that it's symmetric, about x is 6, x equals 6, and y equals negative 7 over 2. And so for this one, we are going to have like a coordinate plane like that, and then we are going to have values for right here, that's x equals 6, like that, and then right this, that is y equals negative 7 over 2, right? So this is 6, this is negative 7 over 2, right? And so if we look at that part, which is going to be this, which is x is greater than 6, and y is greater than negative 7 over 2, right? Then we're gonna get 3x, yeah, these are just all plus, so that gives us 3x plus 2y is less than or equal to 14. This gives us the point 6 comma negative 2, 6 comma negative 2, and 7 comma negative 7 over 2, right? Yeah, so we are going to have points like this. This is negative 2, and this is going to be 7, right? And so if we connect those like that, that will be on one side, and then since it's symmetric about x equals 6 and y equals negative 7 over 2, that's going to hold the same for here, and here, and here. And so this will be, that will be 5, and this is going to be negative 5, right? And so we know this length and this length, so the area, this is 1/2 times this much, which is 3, times this much, which is 2, so this is equal to 3, so this is the answer, it's A. Number 15, let k equals 2008 squared plus 2 to the 2008th power. What is the units digit of k squared plus 2 to the kth power, right? Okay, so since we know the pattern for 2k squared, right? So if k is to the kth power, the units digit of that cycles between 2, 4, 6, and 8, right? And so let's just look at that k value. K, this is equal to 2008 squared plus 2 to the 2008th power, right? So which is equal to 2 squared times 1004 squared plus 2 squared times 2 to the 2006 power, and this is equal to 2 to the, yeah, this is equal to 2 squared, which is 4, times 1004 squared plus 2 to the 2006. So this is, yeah, so this gives us that k is a factor of 4. The units digit of 2 to the kth power, that would be k is a 4th power, right? So the units digit is 6 units digit. And if we go on more about that, this is gonna be so this is gonna have a units of 4, sorry, units of 6 because it's 4 squared, and this is gonna have a units of 4 because 2006 is 4x plus 2, so that becomes 4, and and summing that becomes units digit of 0, right? And so this gives us that it's 4 times 0, which is just still 0, and so this gives us that the units digit of k equals 0. And since the units digit of k equals 0, that means k squared that units digit also equals 0, right? So we have 6 plus 0, that gives us 6. And that's the answer to this question, it's D. And number 16, the numbers log a cubed b7, log a to the 5th power b to the 12th power, and log a to the 8th power b to the 15th power are the first 3 terms of an arithmetic sequence, and the 12th term of the sequence is log b to the nth power. What is n? Okay, so let's say that the log a is equal to a, and log of b is equal to large B, and log of c is equal to large C, right? So that would make all of these just 3a plus 7b, and 5a plus 12b, and 8a plus 15b, right? 8a plus 15b. And so this is going to give us that since this is an arithmetic sequence, these differences are the same. So 2a plus 5b equals 3a plus 3b, right? And so a equals 2b. A equals 2b, and so these are just going to all be, so that's all just going to be 13b, 22b, 31b, and so on, right? And then we see that the values, this is getting added by 9b, right? And so we want the 12th term of the sequence, right? So the 12th term, this is equal to 13b, which is the first one, 13b, which is the first one, plus, and then 12 times 9b, 9b, this is equal to 13 plus 12 times 9b, which equals 112b, right? So this is the answer, it's D. Number 17, let a1, a2, all the way be a sequence determined by the rule this if a(n minus 1) is even, and this if a(n minus 1) is odd. For how many positive integers a1 is less than or equal to 2008, is true that a1 is less than each of a2, a3, and a4. Okay, so if we have a1, then we can go two ways, right? So we can go either, if a1 is even, it's a1 over 2, and if it's odd, it's 3a1 plus 1, right? That's a2. But then since a2 has to be greater than a1, right? So this one, so that one's gone. And so our only way is for a2 to become 3a1 plus 1, right? Therefore a1 must be odd. a1 must be odd, right? Next, since a1 is odd, that means 3a1 plus 1, this must be an even number, right? And so our next value must be 3a1 plus 1 over 2, right? But then we don't know if that's odd or even, so our next one we can just split, right? So if it's odd, so if this is odd, then it's going to be 3 times 3a1 plus 1 over 2, and then plus 1, right? But if it's even, then it's going to be 3a plus 1 over 4. 3a1 plus 1 over 4. And so we want a1 to be less than a4 also, right? And so if we put that in here, then that gives us a1 is less than 3a1 plus 1 over 4. That means, 4a1 is less than 3a1 plus 1. a1 is less than 1, right? But then since a1 has to be positive integers, then that means this is not possible, right? So this cannot be even, and so it must be odd, right? So it must be odd. For this to be odd, so that gives us that this is odd, right? So 3a1 plus 1 over 2, this is odd, which is like 2k plus 1 kind of shape, right? And so 3a1 plus 1 equals 4k plus 2. So 3a1 equals 4k plus 1. And so a1 equals 4k plus 1 over 4k plus 1 over 3. And a has to be, for that to happen, then a1 must be in like 4n plus 3 4, because that's the only way that that multiplied by 3 is going to be 4k plus 1. And so since a1 can be in 4 types, but it only has to be one of the 4 types, right? And so this is 1/4 of everything. This is 1/4 of everything. This is 1/4 of 2008 values, right? So this is going to be equal to 502. So 502, that's the answer, it's D. Number 18, a triangle ABC with sides 5, 6, 7 is placed in the 3-dimensional plane with one vertex on the positive x-axis, one on the positive y-axis, and one on the positive z-axis. Let O be the origin. What is the volume of OABC? Okay, so if we draw a diagram here, then we are going to have these x-axis and y-axis and z-axis like that, right? So let's say this is x, this is y, this is z, although it doesn't really matter, right? Now let's put triangle ABC on there. So let's say this is AB. Let's say this is AB, and this is BC, like that, and then this would be AC, like that, right? So this is A, B, and C, and so this side will be 5, this side will be 6, and this side will be 7. And so we can have the volume of OABC if we just have these 3 values, right? Let's call them A, B, and C, right? Then that means OABC, this is going to be equal to 1/6 times ABC. since we know that each of these triangles, they are a right triangle like that, then we can use the Pythagorean theorem 3 times to figure out a, b, and c, right? So that's going to give us a squared plus b squared equals 5 squared, which is 25, and then b squared plus c squared equals 36, which is 6 squared, and then c squared plus a squared, that's going to equal 7 squared, which is 49. Right? And so that's going to give us a squared plus b squared plus c squared equals all over, equals 25 plus 25 plus 36 plus 49 all over 2, right? And then this is going to equal 110 over 2, which is 55, right? And since a squared plus b squared plus c squared equals 55, like that, right? Equals 55. And then we know each of these values, right? So that means that we can just subtract and then get a squared, b squared, and c squared values. And so this gives us that a squared equals 6, and b squared equals 19, and c squared equals 30, right? So this gives us that a equals, that gives us that multiplying these together, a squared, b squared, c squared equals 6 times 19 times 30, and so root a squared, b squared, c squared, so just abc, this is going to equal root of this, so that is 6, this equals 6 root 19 times 5, and that's just going to be 95, right? So it's 6 root 95, and so OABC, we have ABC now, right? So OABC, this is 1 over 6 times 6 root 95, so these two cancel, so this is root 95, right? So that's the answer, it's C. Number 19, in the expansion of this, what is the coefficient of x to the 28th power? Okay, so since these are going to have terms of a constant, 1 and then x, 1x to the first power, x to the second power, x cubed, x to the fourth power, x to the fourth power, all the way up to x26, x27, x27, x28, like that, right? If you multiply each of these terms by something in there, right, like that, and all the way to x times x27, and then just 1 times x28, right, that's gonna just be all the coefficients, right? And so for the whole thing, the total coefficients of x to the 20th power, this is going to be equal to the sum of coefficients in this one, right? Let's put this in blue, and then of this one, minus 1, right? Because we have 1 which can't be x to the 20th power, so that's just that, minus 1. And so now we can just get that, and so that is going to be 1 plus 2 plus 3 plus 4 plus 5 plus all the way up to, and then it's until 14, so that goes until 14 plus 15, and then it goes back down again, 14, 13, 12, all the way up to 2 and 1, right? And so this is going to be equal to 15 plus 2 times 1, 2, 3, 4, all the way to 14. So this is 15 plus 2 times 14 times 15 divided by 2, right? And then we have to subtract 1 from there. So if we do that, then these two will get cancelled, and then these two will meet, and that will be 14 plus these two will cancel, 14 times 15. This is 14 times 16, 14 times 16, which is equal to 224, right? So 224 is our answer, it's C. Number 20, triangle ABC has AC equals 3, BC equals 4, and AB equals 5. Point D is on AB, and CD bisects the right angle. The inscribed circles of ADC and BCD have radii RA and RB respectively. What is RA over RB? Okay, so if we pull out the diagram of this, then it's going to look something like that, right? So if we have A over here, and then B over here, and then B over here, and then C over here, like that, and then this will be D, right? Since it has 3 to 4 to 5, that's a right triangle, and CD bisects the right angle, so this is 45 and this is 45, right? And then they have radii RA and RB, so let's call this radius RA, right? So that's gonna be like that, and so that will be RA, and this one like this, that will be RB, right? And so now what we have to first notice is that we are asked RA over RB. That's a ratio, right? So this is a ratio. So only the ratio of sides needs to be the same. and that just means that AC, BC, and AB, that doesn't have to be exactly 3, 4, and 5. That just can be 3 to 4 to 5. Just the ratio has to be correct, right? And since we have a 45 degree, then we can just put lines from D, put lines from D down to BC like that, right? Like that, and from D up to AC like that, and so that's going to give us the same length. And since it's also 3 to 4 and also 3 to 4, and so that's going to be, if this and this is equal, that's going to be 9 to 12 to 12 to 16, right? And so if we just write that down, this is going to be 9 and this can be 12, and so this is 12 and then 12 and then 16. So therefore we know that the value of CD, that will be 12 root 2, right? So that will be 12 root 2, right? And now we can get the whole area, right? So the area of ADC, area of ADC to BCD, right? So this area to that area, that's going to be the length, that's going to be the ratio of this length to that length, right? Because this one and this one, their heights are the same, and their base is the only thing that's different, right? And so since if it's 9 and 12, this is going to be 15, and this much, that's going to be 20, right? And so the area of ADC to BCD, this is 15 to 20, which is 3 to 4. This is going to be equal to, look, since ADC, yes, that's equal to, from the center, we have this triangle plus this triangle plus this triangle, right? And then those areas are this length times RA plus this length times RA plus this length times RA, right? So these three triangles, those are all going to be equal to 1/2 RA times 15 plus 12 plus 9 plus 12 root 2, right? So that's going to be 15 plus 21 plus 12 root 2, and then same thing on BCD. This is going to be RB times BC plus this much plus RB times BD plus RB times CD, right? So that's going to be this triangle plus that triangle, and so this is going to be equal to, so it's going to be that to 1/2 RB this time, and then we have that much, which is 28. This is 20, and this is 12 root 2, right? And so we get 28 plus 20 plus 12 root 2. And so if we just cancel out the 1/2's, that means this, so 3 to 4. So 3 over 4, this is going to be equal to this over that. So that is equal to R8 times 36 plus 12 root 2 over RB times 48 plus 12 root 2, right? And so this is going to equal 3 over 4. And we can clean out by 12, right? So this is going to be 3 plus 1, 3 plus just root 2, and then those are going to be 4 plus root 2, right? And so we are going to go like that and like that, right? So this is what we get. And so we want to get this value, which is RA over RB. So RA over RB, this equals 3 over 4 times 4 plus root 2 over 3 plus root 2, right? So this is going to be 3 over 4 times, and then 9 minus 2 over 4 plus root 2 times 3 minus root 2, right? 3 minus root 2, and so this is going to be equal to, this much is 7, right? So that's 3 over 4 times 7, which is 28. So it's 3 over 28 times this much, and that is going to simplify to 10 minus root 2, right? So this is our final answer, 3 over 28 times 10 minus root 2. So that's this value, it's E. Problem number 21. A permutation A1, A2, A3, A4, A5 of 1, 2, 3, 4, 5 is heavy-tailed if A1 plus A2 is less than A4 plus A5. What is the number of heavy-tailed permutations? Okay, so we can have A1 plus A2 values of, this is just combination, not permutation yet. So they can be 1, 2, or they can be 1, 3, or 1, 4, or 1, 5, or they can be 2, 3, or 2, 4, but they can't be 2, 5, because then A4 plus A5, those would be 3 plus 4, which is just equal. So that is not possible. So it's until 2 and 4, right? And so if we have those values, then we can have A4 and A5 values of 3 and 4, or 3 and 5, or 4 and 5. And for this one, we can have 2 and 4, or 2 and 5, or 4 and 5. For 1 and 4, we can have 22 and 5, or 3 and 5. For 1 and 5, we can have 3 and 4 only. For 2 and 3, we can have 1 and 5, or 4 and 5 only. And for 24, we can have 3 and 5 only. If you count the number of these, we have 3 and 3, and we have 12 in total, right? So this is 12 combinations. But then we want the number of permutations, right? And so since we can choose the order, and so since we can choose the order of A1 and A2, and since we can choose the order of A4 and A5, that's just 2 times 2, right? So that's going to become 2 times 2 times this, which is 12. This is 4 times 12, which is equal to 48, right? So 48 is the answer. It's D. Number 22, a round table has radius of 4. 6 rectangular placemats are placed on the table. Each placemat has width of 1 and length x as shown. They are positioned so that each mat has 2 corners on the edge of the table, these 2 corners being endpoints of the same side of length x. Further, the mats are positioned so that the inner corners each touch an inner corner of an adjacent mat. What is x? Okay, so first we can just connect the lines from each endpoint to the other, like that. And then we can connect these 2 lines like that. And then we can have lines from the center to there, and that's just going to be the radius. And we can have lines from the center to the, like that, right? And then this is going to be half of x, right? And so since this is x, right, and this is an equilateral triangle, that means this is also x, right? So that means this is x and this is x, like that, right? And so if you see here, if we bisect that like that, right, and then this is gonna have half of x, right? And so this is 60 degrees, so this is 2 to 1 to root 3, and so this much, that is root 3 over 2x, and so this is root 3 over 2x, and this is 1, right? And so this much is going to be, that much is going to be root 3 over 2 plus 1, right? And then this value, that much is gonna be half of x, right? Half of x. And finally this value, that's going to just be, that's just going to be 1 of the radius, and that's 4, right? So this is 4. And if you see here, we use the Pythagorean theorem on that right triangle, then that's going to be 4 squared equals this much squared, which is x squared over 4, right? Let's just write this 4 squared as 16. 16 equals this much plus this much squared, right? So it's this squared, which is 3 over 4x squared, plus this times 2, which is root 3x, plus 1, right? So this is going to be equal to 16 equals x squared plus root 3x plus 1, right? And so x squared plus root 3x minus 15 equals 0. And so we have this thing, and now if we use the quadratic formula, then we are going to get x equals all over 2, and then we're going to have negative root 3 plus or minus root, and then we have 3 minus 4 times minus 15, right? Minus 15, and so this is going to be minus root 3, so that's going to be minus root 3 plus root 63 all over 2, right? And so this is going to be equal to root 63, which is 3 root 7, and then minus root 3, right? So that's minus root 3 over all over 2, right? And so so this is going to be our final answer. That's C. Number 23. The solutions of the equation this equals 0 are the vertices of a convex polygon in the complex plane. What is the area of the polygon? Okay, so we can take a look at the coefficients, right? They are just 1, 4, and 6, -6, -4, and -1, right? But then that just reminds me of 1, 4, 6, 4, 1, and this is very similar to x plus 1 to the 4th power, right? And so it is indeed kind of like that, because this whole thing becomes z to the 4th power plus 4z cubed I, the same as for here, and then we have plus 6z squared and then I squared, that will account for this minus, and then we have plus 4zi cubed, that will account for that minus 2 because we did plus here, and then finally we have plus I to the 4th power, which is -1, right? And so this should be this goes over there, that will be I minus 1, right? And so this much, that's going to be z plus I to the 4th power, right? Z plus I to the fourth power equals I minus 1. So this is going to give that, let's say that Z plus I equals X and I minus 1 equals A to the fourth power. That will give us X to the fourth power equals A to the fourth power, but then this is on the complex plane, right? On the complex plane, and so X is going to equal A, and then AI, and then negative A and negative AI, right? And so if we just graph that onto a complex plane, right? Then that will just look something like this is K, no, that's not K, that's A, this is AI, this is negative A, and this is negative AI, like that, and it will have like this, right? And this is going to be a square because each of these lengths are equal, right? And so it's going to be a square, and the area is going to be 1/2 times, yeah, the area is going to be 1/2 times this much times this much, which is 2 times the absolute value of A squared, right? So this is 2 times the absolute value of A squared, and so now to get this one, we have to go back to this, right? Since A to the fourth power equals I minus 1, that means the absolute value of that equals, yeah, that means the absolute value of A to the fourth power, this equals root 1 squared plus 1 squared, which is root 2, right? So that's root 2. That means this just 4 can get out, right? So this 4 can go outside, and this becomes 4. So the absolute value of A, this is root 2 times negative 1 over 4, right? And so this is going to be, root 2 times 1 over 4. So this is equal to 2 to the 1 over 8th power, right? 2 to the 1 over 8th power. And so this is going to be equal to, if we substitute that into here, that's going to be equal to 2 times 2 to the 1 over 8 squared. This is 2 times 2 to the 1 over 4. This equals 2 to the 5 over 4, right? 2 to the 5 over 4th power. And so this is our answer. That is D. Number 24, triangle ABC has angle C equals 60 degrees and BC equals 4. Point D is the midpoint of BC. What is the largest possible value of tangent BAD? First, if we draw a diagram of this, that will look something like this, right? And this much, that part that will be useful later. And so first, let's look at triangle ABC, right? This is the triangle, and so C is 60 degrees, this is 60 degrees, and BC equals 4, right? So that means this is 2 and this is 2. And point D is the midpoint of BC, that's right. And then what's the largest possible value of tangent BAD? Okay, so this is where our mystery circle part comes in, and so that will fit just like over there. And so since that is the center of the square, obviously, then let's call the radius x, right? I'm calling the radius x, like that. And then let's say this point is point O, this point is point E, no, that point is point F, and this point is point E, right? If that's E, then this and this are equal, so that will be 1 and 1. And let's say that that OE, this is going to equal y, right? So first of all, OE equals y. That's going to be our first point. Second of all, we want tangent BAD, right? And since tangent BAD, this angle is going to be equal to half of this angle, right? And so this much is half of that angle, so that angle and this are the same. And so that means that, so that means this angle and this angle are the same. So tangent BAD, this equals the tangent of DOE, right? So this is DE over OE, right? This is DE over OE, and so that's DE over OE because this is tangent of this value, right? And so this is 1 over y, right? Because this much is y, right? So this is 1 over y. So that is the value that we want. So if we have y, then it's game over, right? And since OE equals y, there's a reason that this is long, right? Since this is 60 degrees, that means this is, that's a right angle, and that means this is 30 degrees, right? This is 30, and since this is a tangent, that means this is a right angle, and so that means this is also 60 degrees, right? And so since this is also a 30, 60, 90 triangle, that means if this is x, that means this is 2 minus, that means that's 2x, right? So this is 2x, and so since the whole thing is a 60, 30, 90 triangle, that means since this is 2 plus 1, that's 3. This much, yeah, so this much is 3. That means this much, that will be 3 root 3, right? Because this is, because this is 2 to 1 to root 3. And so if this is 3, this is gonna be 3 root 3. 3 root 3, that's gonna be this, right? But then since this much is 2x, then this much is going to be 3 root 3 minus 2x, right? So this is 3 root 3 minus 2x. If we, so that's equal to OE. So this is equal to 3 root 3 minus 2x, right? Since y equals 3 root 3 minus 2x, then that's going to be x equals 3 root 3 minus y over 2. Now we can use the Pythagorean theorem on this DOE triangle, right? This is a 90-degree angle. So DOE, so here, if we use the Pythagorean theorem, x squared, that's the hypotenuse, x squared equals 1 squared plus this much, which is y squared, but then y, that's y squared. And then x equals this, so if we substitute that in there, then that gives us 3 root 3 minus y over 2 squared equals 1 squared plus y squared. And so that's going to give us 3 root 3 minus y squared equals 4 plus 4y squared, right? It's 4 plus 4y squared. And so that's going to give us y squared minus 6 root 3y plus 27. This equals 4y squared plus 4. If you simplify that, that's going to become 3y squared plus 6 root 3y minus 2 root 3, so minus 6 plus 6 root 3y, and then minus 23. This is going to equal 0, and so for this we use the quadratic formula, right? So if we do that, then y is going to be equal to, and it's all over 3, and then negative 3 root 3, and then plus or minus 27 minus, and then 3 times minus 23, 3 times minus 23, like that. And so this is going to be equal to all over 3, and then it's negative 3 root 3 plus or minus root 96, which is 4 root 6 minus 3 root 3 over 3, right? And so since this is equal to y, and this is equal to 4 root 2 minus 3 over root 3, this is y. But then we want 1 over y, and so 1 over y, this is going to be equal to root 3 over 4 root 2 minus 3. So this is our answer, that's equal to D. So D is our answer. Last problem, number 25. A sequence A1, B1, A2, B2, A3, B3, all the way of points in the coordinate plane satisfies AN plus 1, BN plus 1 equals this, for n is 1, 2, 3 all the way. Suppose that A100, B100 equals 2, 4. What is A1 plus B1? Okay, so let's just say that A1 and B1, this is equal to x, y. Then A2, B2, that would be using this. That would be root 3x minus y, root 3x minus y, root 3y plus x, right? And so A3, B3, this is going to be equal to 2x minus 2y root 3, 2y plus 2x root 3, right? And then next, after that, we are going to use this one more time, and so that's A4, B4. That's going to give us negative 8y, 8x, right? So comparing this and this, we notice that an plus 3, bn plus 3, this is always going to be equal to minus 2 cubed bn, 2 cubed an. And so if we continue that using this rule, then we would get A4, let's do this in different color. This would be A4, B4, this is just minus 8y minus 8x, minus 2 cubed y plus 2 cubed x, plus 2 cubed x, and then A7, B7, this is going to be plus 3, like that, right? And so this is going to be minus 2 to the 6th power y, minus 2 to the 6th power x, minus 2 to the 6 y, and then A10, B10, that's going to be 2, 9y, minus 2 to the 9x, and then all the way like that, and then eventually we'll get to A100, B100, and this is going to be minus 2 to the 99 power y, 2 to the 99 of x. And so since this is going to be equal to 2, 4, right, then this will be, so this will be minus 2 to the 99 99, y equals 2, and so y equals minus 1 over 2 to the 98th power, and then 2 to the 99 of x, this is going to equal 4, so x is going to be equal to 1 over 2 to the 97th power, right? And so x plus y is going to be equal to 1 over 2 to the 97, minus 1 over 2 to the 98. This is equal to 1 over 2 to the 98, right? So this is the answer. It's D. And so that was it for the problems of the AMC 12A from the year 2008, and thank you for watching.